Hi everyone, I'm Anshul Singhvi. I've been working at XKDR and I've also contributed to a lot of data visualization in Julia, including the two main packages, Plots.jl and Makie.jl. Today, I want to just run you through the basics of data visualization in Julia, the different packages that exist, and sort of how the interfaces work, especially those which are more Julia specific, which you might not see in other languages. So, probably one of the first data visualization packages which came up in Julia is called Plots.jl. And that's a high-level interface to a lot of different plotting packages across languages. So Julia's interlanguage interop is very good. So Plots has backends in Matplotlib, Plotly.js, GR, which is a C-based plotting package, PGF PlotsX, which is a plotting package which renders Julia plots in LaTeX using PGF plots. And Unicode Plots, which is actually a pure Julia plotting package, which started later, that plots in Unicode. So I'll just take you through a brief overview of what you can do with this. So let's start with the Plotly backend. So I'm running this in VS Code. And all right, so first I should show you the input data. This is just a matrix, right? So it's a 49 by 49 matrix. And Plots natively interprets matrices as series. So a series of different sort of time series with, so the x-axis is your index and then y-axis is your actual value. And you can see there are actually 49 series here. It looks 3D, it's actually 2D. Now if I plot a surface with this, there you go. So because this is the Plotly backend, it's actually interactive. And GR is another plotting package. It's available as a standalone library, and it's also available as a backend to Plots. So if I switch backend on Plots by running Plots.gr, now you might notice something interesting here. This surface plot and that earlier series plot look very different to the plots that I made using Plotly. And that's because Plots.jl, sort of by design, has somewhat less of control over what you do in the backend and a lot of the more sort of nitpicky small details of plotting. It's an excellent package for high-level stuff. It's an excellent package if you want to create these really cool fancy recipes. And you can see a lot of that in the documentation. But if you want to tune your plot exactly like how you could do in LaTeX or Matplotlib, it tends to be a little more difficult. So this is the PGF Plots backend, and you can sort of see the, LaTeX font, and it's taking a while to compile. It looks really nice though. And Unicode Plots is actually pretty cool. So it's a Unicode-based plotting solution. So if you're SSHing in somewhere, you want to just plot something quickly on a terminal, that's your solution. It even does 3D, which is really cool. Makie is another, well-known, somewhat mature plotting library for Julia. And what Makie is it's written more in Julia. So it's pure Julia up until you hit rendering, at which point it goes to it can go to the GPU on OpenGL. It can render to PDF using Cairo, which is a vector rendering library. And please, guys, let me know if I'm sort of losing you anywhere or if you want me to explain something more. So Makie, also you'll notice, hey, this is a heat map. So its high-level plot commands are very similar, but the API, the structure of plots is very different. And Makie was built with the GPU in mind, so it's built with this sort of paradigm of reactive programming, which I'll get into in a bit. But I want to show you the OpenGL backend because that's sort of one of the best ones. The feature parity exists in most Makie backends, but it's nice to see the interactivity and what exactly you can do. So this spawns a nice little figure. And you can see this. So the figure is the top level container of Makie. And it contains a scene which holds all the objects you want to render, and a grid layout object, which defines the layout of the elements in a figure. Now, elements can be axes, right? So you can see this axis sort of came up. Let me just enlarge this. So elements can be axes, elements can be 3D plot, and there are multiple types of axes, so we'll create a 3D plot here. So what I did here was I loaded just a standard OBJ file, which defines the mesh of a cat, and this is the cat, and you can see we can sort of rotate, and it's got a little bit of lighting done as well by default. But I don't know, this cat's kind of boring, one color. Let's update it. Oh, what happened here? Really? Yeah, I don't know, that's very strange because this was working when I tried it earlier today. So let's try this again. What? Okay, fair enough. I suppose it will have to be boring, but what we can try and do. There we go. Okay, so now it's blue. Now, I tried this morning, this was working, but what can you do? So that's some of the stuff you can do with Makie. Now you'll notice this strange syntax. Now what this is, so if I look at meshplot.color in my REPL, no, I was copying the color. This just gives me, well, sorry, it's displaying here, but this gives me the color blue. This is what's called an observable. So an observable is basically a container for a value, which sends a signal and calls a set of functions whenever that value updates. So by updating the value in this color attribute of the mesh plot, I'm telling the mesh plot your color's updated, so you can change that. But it does, so in a lot of other plotting packages, what would happen was if you wanted to change a variable like this, even if you could do it after constructing the plot, you would have to go through and construct the entire plot again. So for example, this little mesh plot is not only this mesh, it's also got this axis, lines, text, and axis labels, and all of this stuff, which would have to be reconstructed, their positions recomputed, etc., etc. With the Makie observable system, what you can do is just change that one value, that instruction gets sent to the backend, but nothing else gets changed. So animations, for example, are extremely fast. Let's try that. So this is just a bunch of random lines, right? Now, if I want to animate, so let me do just a while loop first, the simplest possible animation. Oh, sorry. Let's just do a sine function, right? Maybe I made that sleep criterion a little too long. Let's make it 30 seconds. So you can see it's sort of, I don't know why it's moving that slowly. I think that might be oh, that's not good. I think I detached this process. Whoops. Oh well. Just make a new figure. Yeah, so because this was asynchronous, it was getting stuck on that sleep. That's okay. Fix that. Yeah. And so you can see this is actually pretty smooth, right? Recording is just as fast. Oops. Sorry, time to for TTFX, as they call it in Julia. It just takes time for the first time you run something. After that, it runs pretty quickly. But let's take a look at this, and I can make this an MP4 as well. That was fast, right? So that's some nice stuff you can do with Makie. Shan, how am I doing on time? 5. Oh boy, that lasted longer than expected. Okay, so I'll just show you a couple of nice little things you can do. So one of them is the grid layout in Makie, so I'm sure you're wondering what that was about. Now, here, this AX1 is an axis created at cell 1, 1, so that's row 1, column 1 of the figures layout, right? Plotting something into there. Now I create another axis at cell 1, 2, which is row 1, column 2 of the figures layout. I plot something there. And I can also do other things. So I can also create, there's a large library of interactive widgets in Makie. So for example, and there's nice REPL documentation also. And oops, yeah, so you can see that that button forced all of the elements in that row to conform to its size. We can fix that by telling it not to force its height on everything else. And all of the interaction in Makie also works through observables. So let's make this button change the color of that line plot. Just make sure that this is it. Right, so this didn't do anything now, but there we go. And I'll just enlarge it so it's easier to see. Maybe this is not so easy to see, so we'll change the line width. So this is a very powerful tool because you can change this kind of observable for any plot, even a plot that's within another more complex plot. So Makie is in this way sort of infinitely customizable. You can really do anything. You can tune your figures almost exactly. Okay, so one extension I do want to show is called GeoMakie. So it's basically Makie for geographic projections. For example, this is the equal Earth projection. So the idea is it sort of it retains area. So area is always equal. I've plotted some coastlines on here. And what I can also do, if I go to the GeoMakie documentation, so sorry, I'm not going to be able to show an example because we're out of time, but this is an example of the kind of stuff you can do with GeoMakie. So this is a polygon of, this is India, right? All of these are polygons of India's districts. They're all colored differently to simulate some dummy variable. So that's one of the things you can do, and Geetika and Mithila will show us more of that in their talk later. Meanwhile, last thing I wanted to show is the ggplot-like interface of algebraic graphics. So we've got this toy iris dataset. I'm sure you're all familiar with the iris, sepal length, sepal width, all of that. If I wanted to plot the sepal length against the sepal width and color it by species, I could, of course, do that manually. But because this is tabular data, the algebraic graphics interface works really well. So I wrap my data frame in this data call from algebraic graphics. I define this mapping on the column names. This colon represents a symbol, which is sort of like a string. And I tell it, okay, I want you to visualize it by scatter. And then I tell it to draw. There we go. So that was quite nice. And 3D is also effortless with algebraic graphics. So what we're doing here, we're taking the data, creating this mapping. So basically this goes sepal length, that vector goes to the first argument, the vector of sepal width goes to the second argument. We're multiplying that by algebraic graphics density analysis. And we're defining another mapping that says that color should be grouped by species. And we want to plot it using wireframes. So let's draw this in an axis 3. I can see this pretty okay on my desktop, but I don't know if you guys can see it so well, so I'll just increase the line width. Yeah. So that's sort of more visible. Pretty cool. There's also pair plots. So you're sort of oh, that's awkward. I suppose it's not resizing, but you can probably see approximately what's going on. So yeah, that's that. Thank you.